So 121 question on radians and the area and perimeter of the shape. Let's see how we get on with this. So here's our shape, and I'm going to take the approach of splitting it up in a certain way. There's two different ways of splitting the shape up. I'm going to split it up like this. And so I've got a sector and two triangles. So I can use the fact that I know that AMB is pi over 3 here, and use this is a right angle, and use trigonometry on the triangle ABM to find what the length AM is. So that's what AM is, and then we can use Pythagoras to find the length of BM. Now CMB is pi over 3 as well, because if this angle is pi over 3, then for symmetry this is pi over 3, so this angle is pi over 3. And that is another way of confirming the length of BM, because this triangle here, BMC, is an equilateral triangle, and so the length of this side, BC, will be the same as the length of AD, which is 2 lots of AM. So that's another way of calculating BM. So now I'm setting about answering the question about the area of the shape, and I'm doing it by looking at the area of the sector MBC, and then I'm going to add the two triangles onto that in a moment. So for the area of the sector, I'm using half r squared theta, because theta is pi over 3 and that's in radians, and r is the radius of this sector is the length BM. So when I use my expression for BM and multiplying it, squaring it and then multiplying it by a half and by pi over 3, I get that expression there for BM. And then I need the area of the two triangles, and so that's half base times height, and then I've got two triangles, so that's the area of the two triangles, and therefore the area of the whole shape is those two things added together, the 2 pi x squared over 9 and the root 3 over 3 x squared. So that's the area of ABCD. I could have taken the alternative approach of splitting this up into a segment and a rectangle, and the rectangle is just the base times the height, and then for the segment it's a half r squared times theta minus sine theta, and that simplifies down to the same answer that we had before. Okay, so I've found a simplified expression for the area. We need to go on to the perimeter now. Before we do that, we could actually just simplify, if we wanted to, simplify the answer a little bit more. What I've done is I've taken the 1 over 9 outside the brackets here, so that the bracket itself has got no denominator. Sorry, that's another option for simplifying the area expression. So now we can go on to the perimeter. So I've retained here on the screen some results from the first part of the question. So we need to find the length of the arc BC first. So that's just r times theta, r being the radius, BM, and theta being this angle here, which we know is pi over 3. So when we put the expressions for BM and CMB, we get this rather untidy looking expression for the length of the arc, and then we simply add length of the arc to these two sides and the base. So the perimeter is that arc plus the two vertical sides and the base, and then that's what that looks like. We've got x as a common factor. We can take x out of the bracket, and we've got this, and that would be an acceptable answer, although it can, again, like the previous expression for the area, we can take 1/9 outside of the brackets so that we've got no denominators inside the brackets. So either of those two answers in my book would be sufficient to answer the question. So quite complex, complicated, square roots and pies and everything, but hopefully you understand how that question's been answered.